Okay, another work and power worksheet. I did this one already, so I'm just going to talk about a few things on here. Sorry, the sun is not cooperating right now. Okay, so work is our force times distance, or it's really displacement. And so we're applying a force to something, we're moving it, a displacement. We're really changing its energy. That's really what work is. And then power is our work done over time. Okay, so they've got some little equations up here at the top for you. So how much work is done by a crane that lowers 1,000 newtons of material a distance of 150 meters? So the crane is like lowering this material to the ground, and the material's weight or force of gravity is 1,000 newtons. This means this is M times G already done for you. Like, you don't have to calculate M times G. Whenever we're lifting, so lifting something up or lowering something down, whenever we're moving in a vertical direction in terms of work, it's our force piece of work is going to be force of gravity, because that's what we're overcoming in order to do the work. So we'd have 1,000 newtons as our force times 150 meters as our distance, and that gives us our amount of work done. Let's see, I'm just going to talk about 2 or 3 others on here. So here, a 49 Newton rock is lifted 2 meters in 5 seconds. So again, the weight of my rock, my M times G, is already given, and that's my force. So I'm going to multiply 49 by 2 meters and get 98 joules. And then in order to get power, I'm going to divide that work value by the time. Okay, the time is, I'm trying to shade some of this light. The time is 5 seconds, okay? So I divide 98 by 5, and that gives me 196 watts. Work is not always lifting, okay? Work is not always in a vertical direction. Sometimes it's in a horizontal direction. Here we've got a teacher pushing a desk across a floor for a distance of 5 meters, and she exerted a force of 20 newtons. So in this case, the direction of the force and the displacement are horizontal. So we're going to use her horizontal force of 20 newtons, the distance of 5 meters, and multiply those. So you have to pay attention to the scenario. Like, if you're moving in a vertical direction, you're going to be lifting, so you're going to be using force of gravity. If you're moving in a horizontal direction, it's typically going to be an applied force of some sort, like a pushing or a pulling force that's moving your object in a horizontal direction. Remember, your force and your displacement have to be in the same direction for work to be occurring. Let's see, a couple more things I wanted to point out. One of these on the back has a box that's being pushed, so you figure out the work, you figure out the power, and then if the box is pushed back again, what's the total amount of work done? So that, remember, if you have a round trip, if your displacement is like, if you push it 5 meters in a positive direction and then 5 meters in a negative direction, your displacement's going to be 0. So that actually means 0 work is done if you have no displacement. And then the last question has to do with a woman who's lifting a child. So this is the child's weight, 300 newtons. She lifts a distance of 1.5 meters. So that's how much work the woman does lifting the child. How much work is the child doing? Nothing. The child's just like hanging out, being lifted and carried around. Okay. The only person who does work here is the woman in lifting the child, and the woman actually doesn't do any work here carrying her, because this is where force and displacement are perpendicular to each other. Like, her force would be up and down, but her displacement would be like at a forward, like an X direction. and so that doesn't count as work. Unfortunately, sorry. So, and you can do the rest of this sheet. I just wanted to point out a few things on it that I thought were important.